Hey guys, welcome back to the Mathemagicians YouTube channel, and today we'll be talking about physics. This is for the grade 12 STEM. So the lessons that I'll be discussing are Newton's laws of motion and its application, and Zeroth law of thermodynamics and temperature measurements. So first off is Lesson 4, which is Newton's law of motion and its application. So I'll be quick with this one because this is an old lesson for everyone, and I'm pretty sure all of you are here for all the math equation and stuff and teaching you how to solve. So I'll be really brief on the explanation. So first off is, before knowing Newton's law of motion and its application, we must know what is force. Force is a push or pull of an object. There are two categories of force. There is contact and non-contact force. So contact force occurs when there is physical contact between two objects. So contact force is like you and a car pushing a car, or you pushing a wall, or doesn't have to be pushing. It can be you holding up a pen, you holding up a pencil, a crane carrying steel materials. So you get what's my point. So non-contact force is without physical force between object or separated by empty space. So these are forces that doesn't you can't feel that they are interacting with you. So it's like gravity. Gravity is a force, a non-contact force that pulls us towards the center of the earth. Okay. Next is friction. Friction is a force that resists the motion of an object. There are two common types of friction. The first type is static friction. Static friction is the force between two surfaces in object, in contact, and stationary. The magnitude of static force is static friction is less than or equal to static mu. So this symbol right here, okay, this symbol right here is mu. So static mu times Newton. So next up is kinetic force. Kinetic is the force that prevents the motion of sliding object and tries to decrease the speed at which the object slides against. The magnitude of kinetic force is kinetic force or kinetic friction is equal to kinetic mu times Newton. So the first law of motion is the law of inertia. This states that an object at rest will remain at rest, and object in motion will remain in motion with constant speed and direction unless acted by an unbalanced force. So example of these are golfers when playing golf. So you know the ball before the golfers hit the ball. So the ball is demonstrate the law of inertia because the ball is remaining at rest and will remain at rest until the golfer swing its bat to hit the ball. So another one is a bicycle moving in a constant speed across the street. Okay. Next up is the law of acceleration. So the law of acceleration is the acceleration of a object is directly proportional to and is the same direction as the net force acting on it. It is inversely proportional to its mass. We can rewrite the second law of motion in mathematical notation as net force or force net is equal to mass times acceleration. M is mass and A is acceleration, or you can say it fuma, so that it's easy to remember, fuma. Next is the law of interaction. I'm pretty sure everyone knows what this law states. So this law states that for every action there is an equal and opposite reaction. So It's like you pushing on a wall. So every time you push the wall is giving back the same amount of force back to you. Okay, so example is a set of dominoes falling on each other, the ball hitting each other in billiards or 8-ball pool. So next, problem 1. So these problems will be in terms of the law of acceleration. So a 100 kilogram, let's say a 100 kilogram box or whatever, has an acceleration of 20 meters per second squared. What is the net force acting on it? So the given is mass is equal to 100 kilograms, while acceleration is 20 meters per second squared. We have to find force. So note that force is always in terms of Newton. Newton can be expressed as kilograms times meters per second squared. So the mass should always be in kilograms. If it's not in kilograms, we have to convert the mass to kilograms. So let's go back to the equation. So we have the formula, which is FUMA, which is F is equal to mass times acceleration. So using the formula, you substitute the variables that is given to us in the question. So it will be F is equal to 100 times 20. So it will be 2000 kilograms times meters per second squared is equal to 2000 newtons. Okay, next up, problem 2. A force of 50 give an object of unknown mass an acceleration of 30 meters per second squared. What is its mass? So this time, this equation is giving us the force and the acceleration. So what we're looking for is the mass. So the given, which is 50 newtons acceleration. So next is, so here, using the formula, FUMA, we substitute the variables, and then after this, we divide both sides by 30 meters per second squared. 30, sorry for the handwriting, meters per second squared. And this is an example of the multiplication property of equality. Okay, so after doing that, it will look like this, where mass is equal to, where mass is equal to 50 kg times meters per second squared all over 30 meters per second squared. So we can cancel this out because these two are monomials. So it will equal to, mass is equal to 1.67 kg or 2 kg because our significant figure in the question is only 1. Okay. Sure. Next problem, problem 3. A force of 1,500 Newton is applied to a 2,000 kg car at rest. What is its acceleration and what is its velocity b in 10 seconds later? So velocity is equal to acceleration times time. So the given, that and that. So using the same formula, it will be like earlier, but now we're finding for acceleration. So the process is the same. You substitute the variables and then use multiplication property of equality. So you divide both sides by 2,000 kilograms. So acceleration will be equal to 1,500 kilograms times meters per second squared all over 2,000 kilograms. So we cancel out the kilograms. So acceleration will be 0.75 meters per second squared. So we now have acceleration. I believe this does not give, okay, so this equation does not give the answer for P. So let us solve P ourselves. So we know that we have the time, which is 10 seconds. So all we have to do is use the formula. We have to use the formula and substitute the variables. So velocity would be equal to 0.75 meters per second squared times 10 seconds. So this would be remove the 1 of the seconds, so it will be 0.75 times 10, which is 7.5 meters per second. So this is the velocity of the car. Okay, next up is pulleys and string problem. So for all non-ADZU, I won't be discussing about, for the ADZU people, I won't be discussing about free diagram and the stuff beforehand. So I'll just show you the formula for the non-ADZU. I'll show you guys the formula that we'll be using for the pulleys and string problems. So these are the formulas are tension and acceleration. Okay, tension is equal to 2 times is equal to 2 times the first mass times the second mass times the gravity all over the first mass plus the second mass. So note the acceleration would be the quantity of the second mass minus the first mass times gravity all over the first mass plus the second mass. So note that the gravity will always be equal to 9.8 meters per second squared. Right. So there are problems where that the problem will not give a second object mass, but it will give a tension and acceleration. So when you are presented with that type of problem, all you have to do is play with the formula. So there's an example here on playing with the formula. So okay, let's go with the first example. First problem is a 15 kilogram mass and a 18 kilogram mass are connected by a string. Determine the tension in the string. So the given, tension is always in terms of Newton. So as I said earlier, Newton is always is kg times meters per second squared. So mass is always in kilograms. So now we find 9 grams. Gravity is always 9.8 meters per second. So now we substitute using the formula, as I said earlier, we substitute all the variables with the given. So the equation will now look like this, which is 2 times 15 kilograms times 18 kilograms times 9.8 meters per second squared all over 15 kilograms plus 18 kilograms. Okay, so if you input that in the calcu, you'll have this. If you input the top part, you'll get 5,292 kilograms times meters per second squared, and if you add the bottom part, it will get 33. So this is what the equation would look like. Then if you input that in the calculator again, you'll get 160 newtons. Alright. So that is your final answer because our SF is 2 and our final answer is also 2. So SF is significant figures. Alright? Okay, second problem. Okay. A 0.5 kilogram mass and a 1 kilogram mass are connected by a string. Determine the acceleration of the mass and the tension of the string. So now we have to find the tension and the acceleration of the mass. So we have the given of the two mass, 0.5 kilograms and the 1 kilogram gravity, and we have to find the tension and the acceleration. So tension is, so using the formula as said earlier, same method as we did earlier, substitute all the variables with the given, and then next is you input this in the calculator. 2 times 0.5 is 1 times 1 is 1, and then times 9.8 meters per second squared is 9.8 meters per kg squared times meters per second squared all over 1.5 kilograms. So that is what you get. This would be 1.5 kg, and this will be equal to 9.8 kg squared times meters per second squared. So squared. So cancel out the kg. So you will have this. So tension 9.8 kilograms times meters per second squared all over 1.5. So if you input that in the calculator, you would get 6.53 newtons. So since in the given, in the problem, we only have our given is 0.5 kilograms and 1 kilograms. So these two given has a significant figure of 1. Therefore, the answer is 7 Newton. Okay, next is acceleration. So using the formula, the quantity of m sub 2 minus m sub 1 times g times gravity. It's all over m sub 1 plus m sub 2. So substitute again, you get this. So this would be 0.5, which should change this to 4.9. And then cancel out the kilograms, you get this. Okay. So 1 kilogram minus 0.5 kilogram is 0.5. So if you input the 0.5 kg times 9.8 meters per second squared, you'll get 44. After multiplying the two, after multiplying 0.5 kg and 9.8 meters per second squared, you will get 4.9 kilogram point meters per second squared. So cancel out the kilogram, and then if you input 4.9 meter per second squared all over 1.5, you will get 3.267 meters per second squared, or 3 meters per second squared, because our significant figure is 1. So problem 3. So there are two objects connected by a string which is stretched over a pulley. The tension of the string, this should be string, is 2.04 Newton, and the object's mass is 6 kilogram. Determine the mass of the other object. So now we have to find our second mass. So given the first mass is 6 and our tension is 2.04 Newton. Gravity is still 9.8 meters per second. Okay, so we have to play with the formula. So we times both sides with m sub 1 plus m sub 2. So after that, this will be the outcome. So after that, you distribute the tension to m sub 1 and m sub 2, which will give you this. After that, you move, by addition property of equality, you move tension times m sub 1 to the other side, which will make the sign symbol of tension negative, and then you move the 2 times m sub 1 times m sub 2 times gravity to the other side, will change the symbol of it to negative. So after that, this will be equation. So in these two terms, you could say, you have two of the same thing, which is the 2 sub m. So you factor that out, which will make m sub 2 times tension minus m sub 2 times m sub 1 times gravity. So you divide both sides by this, you'll get m sub 2 is equal to tension times mass sub 1. Yeah, tension times mass sub tension mass sub 1 all over tension minus 2 m sub 1. So after that, using the formula, we substitute the variables with the given. This will be, as you can see, this is what it shows, negative 2.04 Newton times 6 kilograms, 2.04 Newton, 2.04 Newton times 6 kilograms all over 2.04 Newton minus 2 times 6 kilograms times 9.8 meters per second square. So if you multiply these two, the 2.04 Newton times 6 kilograms, you'll get 12.24 newtons times kg, and then if you multiply 2 times 6 kg times 9.8 meters per second squared, you get 117.6 newtons. So now they have the same term, so you can subtract them. So after subtracting them, you will get the equation will be turned into negative 12.24 kilogram all over negative 114.46. Negative 114.96. So you might be wondering what happened to the n. So the n here cancelled out the n at the bottom. So which left, there's no more n, this which means no more n. So as well as this negative will cancel out the numerator negative, which will change the equation to positive. So if you input 12.24 kilogram divided by 114.96 to the calculator, you will get 0.1065 kilogram. Since our SF, the lowest SF is 6, it will convert to 0.1 kilogram. And that is the end for the first lesson. For the fourth lesson. Okay. So next up is the Zeroth law of thermodynamics and temperature measurements. Okay. First off is the thermal equilibrium. So this states that it is when the thermometer and its surrounding have the same temperature and no further changes to both the thermometer and surroundings. Okay, Zeroth law of thermodynamics. If object A is in thermal equilibrium with object B, and B is in thermal equilibrium with object C, then object A and C are thermal equilibrium. Okay, let's skip all that. Conversion of temperature. So it is to find the temperature in different units. It can be Kelvin, Celsius, Fahrenheit. So those are the 3 units of temperature. So conversion, meaning you convert either Kelvin to Celsius, Celsius to Kelvin, Fahrenheit to Celsius, Fahrenheit to Kelvin. So these are the formulas. So to find Fahrenheit, it's 9 over 5 times the temperature of Celsius plus 32. And then to find Celsius, it's 5 5 over 9 times the quantity of temperature of in Fahrenheit minus 32. So you only use this. You only use this if the given gives you Fahrenheit, and then this one is Kelvin. To find the temperature in Kelvin, it's temperature in Celsius plus 273.15. So, you use this if given is Celsius, and then you can also do Celsius. Temperature in Celsius is equal to Kelvin. Temperature Kelvin minus 273.15. Use only this to find the temperature in Celsius if you are missing if the given shows the Kelvin. Okay. Problem 1 in conversion. So the temperature on a day is 28 Celsius. It's not that hot. What is the temperature in Kelvin and Fahrenheit? So we have the given, which is this. So in Kelvin, just add using the formula. You just substitute the Celsius to 28. So you have this. So Kelvin will have 301.15 degree Kelvin. For Fahrenheit, use the same formula for Fahrenheit. So 9 over 5, 2 over 8 times 2 over 8. 9 over 5 times 28 plus 32, which gives you 82.4 degree Fahrenheit. Okay. So next is problem 2. So the temperature of a furnace is 392 degree Fahrenheit. What is the temperature in Kelvin? So in the choices, the formula earlier did not show how to change Fahrenheit to Kelvin, but it did show how to change Celsius into Kelvin. So first, let us convert 392 degrees Fahrenheit to Celsius and use that Celsius to input it for the Kelvin, to find the Kelvin. So use the formula 5 over 9 times the quantity of 392 minus 32, which will give you 200 degrees Celsius. Now use this variable for the formula for Kelvin, which is temperature in Celsius plus 273.15. So you get 473.15 degree Kelvin. Okay. Next, thermal expansion. Objects expand when temperature increases. Types of expansion: linear expansion and volume expansion. So these are the formula when finding the linear and the volume expansion. So the difference of linear and volume expansion: linear only measures the, let's say, length or the width of the thing, like example, cube. That is the length expansion, if it's getting bigger or not. So the volume is talking in a 3D dimension. So it is to see if there is any expansion in the volume, the inside of the material or object. So the formula here is the change of length is equal to alpha times the initial length and then change in temperature. So the change in length is equal to the final length minus the initial length. So same as temperature, the final temperature minus the initial temperature to find the change of temperature. Same as the volume expansion, the formula would be change in volume is equal to this is beta times the initial volume times the change in change in temperature. So change in temperature is the same as this. And then the change in volume is just the same as the length, but in terms of volume. So volume, final volume minus the initial volume. Oh, that's length, initial volume. So that's how you find the change in volume. So next up, so this is the coefficient example. So we'll be using this expansion when these are the alpha and the beta of the materials. So aluminum, brass, copper, gold, iron, or steel, lead, glass in Pyrex, glass, the ordinary, quartz, concrete and brick, marble, gasoline, mercury. Okay, so unless the choices is not one of the thing, it should give us the what is the coefficient of linear expansion or the coefficient volume expansion, depending what is given. So problem 1 is a copper bar has a length of 200 cm when the temperature is 20 degrees Celsius. What would be the final length when the temperature is 70 degrees Celsius if the alpha is 17 times 10 raised to 6 degree Celsius raised to negative 1? So copper is stated here naman. Copper is here. But if linear expansion, it's always alpha, which is this one, the alpha, times Celsius, degree Celsius raised to negative 1. Okay. So next is given. We have the length, the initial length, the initial temperature, the final temperature, which is, so we have initial length, which is for 200 cm, initial temperature, which is 20 degrees Celsius, final temperature is 70 degrees Celsius, and our alpha, 17 times 10 raised to 6 times degrees Celsius, negative 1. So we'll use the formula theta, change in length is equal to alpha initial length change in temperature. So we change this change in length to length, final length minus initial length equal to alpha. So this is to find the final length. So now we have the formula. So we distribute the initial length to the other side, which is like earlier in the lesson 4, it is the addition property of equality. So the sign of initial length will change to positive since it's negative right here. So distribute, and then now initial length of the two terms, both of the two terms of these two has the same variable, which is the initial length. So you can factor that out, which will have your equation into this. Okay, using this equation, you substitute here, using the equation, you substitute all the variables with the given, which will turn into this. So 200 cm times 1 plus 17 times 10 raised to 6 times Celsius, degree Celsius raised to negative 1 times 70 minus 20 Celsius. So you can cancel these two out. So 70 minus 20 is 50. So now you multiply 17 times 10 raised to 6 times 50, which will give you 8.5 times 10 raised to 4. So 200. So the final length is equal to 200 cm times 1 plus 8.5 x times final length is equal to 200 cm 1 plus 8.5 x times final length is equal to 200 cm times 1 plus 8.5 times 10 raised to 4. So if you add that, 1 plus 8.5 times 10 raised to 4, it will equal to 1.00085. So if you add that, if you multiply 200 times 1.00085, if you input that in the calculator, is equal to 200.17. So that is your final length. Okay. Next, problem 2. A gold bar has a volume of 50 meter cube at 0 degrees Celsius. What will be the change in volume and the final volume in degrees Celsius? Okay, where beta is equal to 42 times 10 raised to 6 times the degrees Celsius raised to negative 1. So given, these are the given. We're finding for the volume 1 and the change in volume. Okay. Now, okay, so using the formula, as said earlier, change in volume is equal to beta times initial volume times change in temperature. Then substitute that with the given. So multiply these two. Wait, sorry. So you multiply this variable with this. You can cancel out this 2. So 100 minus 0 is still 0. And then if you multiply 42 times 10 raised to 6 times 50 meters cubed in the calculator, you would get times 100, right? So if you multiply 42 times 10 raised to 6 times 50 meters cubed times 100, you would get 0.21 meters cubed or 0.2 because of the significant figure of 1. Okay, now we have to find the change in volume, the final velocity, the final volume. So the final volume is equal to the change in volume plus the initial volume. So substitute the variables. So 0.21 meters cubed plus 50 meters cubed is equal to 50.21 meters cubed. As you can see, we didn't use the significant figure here because to find the more accurate volume, final volume, we must use the variable, the answer that is not in significant figure. Okay, problem 3. A balloon has an air of 0.025 meters cubed at 10 degrees Celsius. What will be the volume when the temperature is at negative 10 degrees Celsius? Okay. So the given, the initial volume is equal to 0.025 meter cubed. Initial temperature is equal to 10 degrees Celsius and final temperature is negative 10 degrees Celsius. And then the beta is equal to 3,400 times 10 raised to negative 6 times degrees Celsius raised to negative 1. Note that in beta, the degree Celsius is always constant. So if the given does not give Celsius, we must convert the degrees into Celsius, whether it's Kelvin or Fahrenheit. Okay. So now using the formula, you substitute everything with the formula. So just as earlier, we cancel out this degree Celsius and this degree Celsius, which will give us this. And then if you input this in the calculator, 3,400 times 10 raised to 6 times 0.025 meters cube times negative 20, we would get negative 1.7 times 10 raised to negative 3 meters cube. So that is our change in volume. So to find the final volume, or because it is asking for what will be the volume when the temperature is, what will be the volume when the temperature is negative 10 degrees Celsius. So they are asking for the final volume. So using the formula, using the same method earlier, using change in volume is equal to the final velocity, final volume minus the initial volume. So using addition property equality, you transpose this here, you get final volume is equal to change in volume plus initial volume. So we would get the final volume is equal to negative 1 point, ignore the other point, negative 1.7 times 10 raised to 3 meters cube plus 0.025 meters cube, which is equal to 8 times 10 raised to negative 4 meters cube. Okay, so that will be all, I suppose. Okay, so that is it for today's lesson. So see you guys next time, and like if you like the video.